Hi everyone, myself Karthikeyan S. Now I am presenting a project report on impact of car features. These are the table of contents we are going to see in detail in further slides. Now we will take a glance at this table of contents. At first, project description. In this section, we can see the problem statement and description of the data sources used in the project. Next, we can see the way of approach for solving the problem statement. Next, tech stack used. In this slide, we can see the various tools and softwares used in the analysis. Then we are going to see the detailed analysis carried on this project with a step-by-step procedure. Finally, we are going to conclude on this project. Next, coming to the project description. In the last few decades, car have lot of changes. Now, companies are focusing more on making cars that use less fuel, are better for the environment, and have cool new features. It's really important to understand what makes people want to buy certain cars, especially because there are so many car companies competing and people taste are always changing. Lately, people are getting more interested in different kinds of fuel like hydrogen and natural gas. They are also liking electric and hybrid cars more. But even with all these new options, regular gasoline cars are still the most popular. They are great because we can choose different types and grades of fuel for them. As a data analyst, the customer has asked me to answer the following question for the dataset. How can a car company set the best prices and create new models that make the most money and still make customers happy? To approach this, we can look at how different aspects of the car, like its features and the market it aimed at, related to its price. This helps us figure out which features and market segments are most popular with buyer and bring in the most money for the company. The company could decide which feature to focus on when developing new products and come up with pricing strategies that satisfy both customers and profit goals. They can achieve this using data analysis tools like regression analysis and market segmentation. This approach could lead to increased profitability and competitiveness for the company in the long run. Moving on to the dataset description, the dataset consists of 11,159 records and includes 16 different variables. It covers over 11,000 car models, containing details such as make, model, year, fuel type, engine power, gearbox, and other relevant features. Analysts can utilize this dataset to analyze trends, monitoring price and feature fluctuations over time to aid producers in making well-informed decisions. The second one is to compare fuel economy. Assesses MPG data to compare fuel economy among different car models, assisting consumer in making decision. And the third one is to examine popularity. Analyze how car characteristics influence consumer preferences to support manufacturers in market and product development strategies. And the fourth one is predict pricing. Develop models to predict car prices based on features and market segments, aiding both customers and manufacturers in pricing decisions and purchases. After reviewing the dataset, I have noticed that certain entries, particularly in the coupe and sedan categories, we are missing information regarding the number of doors. Sedans are commonly associated with 4 doors, while coupes typically have 2 doors. Leveraging this pattern, I addressed that missing data by assigning 4 doors to sedans and 2 doors to coupes. Moving to the approach, the research employed various analytical techniques including regression analysis, visualization, and descriptive statistics. Descriptive statistics were utilized to summarize key features of the dataset, providing insights into the distribution, average values of parameters such as engine output, MPG, and MSRP. Visual exploration of the dataset's relations and patterns were conducted using techniques such as scatter plots, line graphs, and clustered column charts. These visualization facilitated the identification of the patterns, anomalies, and potential relationship between different data points. The project utilized linear regression analysis to predict car prices based on market category and selective features. The objective was to establish relationship between independent factors such as vehicle pricing and dependent variables such as market category, engine power, and MPG, enabling predictive analysis by fitting a linear model to the data. The project's objective was to include constructive predictive models for price analysis and gaining insights into various aspects of the automotive industry, guided the selection of analytical techniques. The challenges encountered during the project included managing missing data, ensuring data quality and reliability, selecting appropriate regression models, and fine-tuning their parameters to achieve optimal performance in predicting automobile prices. Moving to the tech stack used, regression analysis, visualization, descriptive statistics, and data manipulation were primarily conducted using Microsoft Excel. Canva was utilized to generate visually appealing reports based on the analysis result obtained from Excel. Excel was chosen for its robust feature set, user-friendly interface, and widespread popularity, making it well suited for managing and analyzing large datasets. Canva was selected for its intuitive design platform, facilitating the creation of professional-looking reports and visualization that effectively conveyed the findings from the Excel analysis. Both Canva and Excel offer comprehensive tools necessary for conducting the analysis and generating final reports, eliminating the need for additional libraries or programs in the project. Moving on to the insights, our first task is to compare how popular car models are across different market segments. Creating a private table displaying the number of car models and their corresponding popularity scores for each market segment. Generate a combination chart, that is combo chart, to visually represent the relationship between market category and popularity score. Moving on to the Excel. This is the original dataset provided by the Trainity, and this is the copy of that. In order to retrieve this dataset, if we have done any mistakes. Moving on to the task 1, we have the columns model, market category, and popularity. In order to create the pivot table, just click on this and go to insert and go to pivot table. Here the range will be automatically selected. I want this in the existing worksheet, so I will select here, then click on OK. So here the pivot table will be created. So here choose market category as rows, and to know the number of models in each market category, choose this model as values. To know the average popularity score, choose this popularity as values. So here we got just the sum of popularities. So in order to get the average of popularities, so click on this arrow, go to field settings, value field settings, and click on average. Then automatically the average of popular score will be selected. So I want this data, that is a number after 2 decimal points. So in order to get this, I will select this entire column. So right click on that, just go to the format cells. Here under number, here after decimal point, how many numbers do you want? Then I will select one number. So here I got. So this is the same I have got here. So after creating this, wait a minute. On this, go to insert. Here you can see the pivot chart. Here you can select the combo chart. This is the combo chart, that is combination chart. Here for count of model, I will select line chart. For average of popularity, I will select clustered column chart, then click OK. This is how I created the combo chart. Coming to the report, upon analyzing the data, I have observed that the market categories crossover, flex fuel, performance, flex fuel diesel, and hatchback flex fuel stood out with the highest average popularity, each surprising the average of 5657 views on edmunds.com. So this is what I done in the Excel, and this is the chart, combination chart. The research reveals the varying levels of popularity among different car models across diverse market segments, providing valuable insights into consumer preferences within the automotive industry. Moving on to the task 2 is to illustrate the relationship between the cost and engine power of the car. Create a scatter chart with engine power on the x-axis and the pricing on the y-axis, then add a trend line to the chart to visualize the connection between these variables. Let's go to the Excel sheet. So this is, I have took engine HP and MSRP, that is car's price. So this is what I created the scatter plot. So here you can see the engine HP with the 1001 horsepower engine HP has the highest car price, that is 20,65,902 dollars. So here in x-axis we have engine power in HP, where when it comes to y-axis, that is price, the MSRP, that is the car's total price. So coming to the Excel, coming to the report, by doing this analysis, it's evident from the data that there is a positive correlation between the car's price and its engine power measured in horsepower. For instance, cars with a higher horsepower tend to have higher prices. For example, a car with 1001 horsepower is priced at 20,65,902, 17,05,769 and 15 lakh, indicating a correlation between engine power and the price in these instances. So you can see, as the HP, that is the horsepower of the car increases, the price of the car also increases. So we can see that it is a positive correlation. Moving to the task 3, to identify the most critical aspects of an automobile in determining its price, regression analysis can be employed to determine which variable has the strongest correlation with the cost of the car. Subsequently, to visualize the relative importance of each variable, create a bar chart displaying the coefficient values for each variable. Let us go to the Excel sheet. So this is the task 3. I have took the engine HP, in number of engine cylinders, here number of doors the car having, highway MPG, city MPG, that is highway mileage and city mileage, and this is MSRP. So this is what the in order to get this regression analysis, just go to file option, here get add-ins, here you need to search analysis. So here you will get Excel Miner analysis toolpack. I have already inserted this. So here in add-ins you can see here, so select here linear regression. Here under linear regression, input y range, that is y means dependent variable. Here the dependent variable is MSRP. So we need to select the range. 11,200. Okay. X means independent variable, that is engine HP, engine cylinder, number of doors, highway MPG, city MPG. Here for that, from column A column first row to here to E column 11,200 rows. Okay. For output range, I will select this cell, then click on OK. Automatically the linear regression will take place. Here you can see. Now in order to create the chart, that is relation between the coefficients and the other variables, so we need to select this, and here under insert here creating a bar chart. So this is what I created here. You can see here the same one I created here. Next, coming to the report. According to the study, the variable with the highest correlation to the car's pricing is the number of the engine cylinders with the coefficient of 7003.3. Conversely, the number of doors has the least correlation to the car's price with the coefficient of minus 4474.09. This suggests that engine cylinders play a significant role in determining the car prices, while the number of doors has the minimal impact. Hence, the number of engine cylinders is the primary factor influencing the car prices, whereas the number of doors holds the less importance. So this is the chart I have done in the Excel. Moving on to the task 4. To highlight differences in typical automobile prices among various manufacturers, create a pivot table showing the average prices of the automobiles for each manufacturer. Generate a bar chart or a horizontal stack bar chart illustrating the relationship between average price and the manufacturer. Let us move to the Excel. So this is task 4. I have created the pivot table for brand and the MSRP. So I have took the average of the MSRP. I have already shown in the previous slides. So this is the relationship between the manufacturer and the average price. Here the highest average of MSRP goes to Bugatti, that is 17,57,224, followed by Maybach, that is 5,46,222. So coming to the report. By conducting this analysis, car manufacturers can gain valuable insights into the pricing landscape of the automotive industry. Understanding the average prices of different brands allows manufacturers to strategically position their own products within the market. They can adjust their pricing strategies to align with consumer expectations and competitor pricing, ultimately enhancing their competitiveness and profitability in the marketplace. Moving on to the task 5, to explore the relationship between an automobile's engine cylinder count and fuel efficiency. Create a scatter plot with the y-axis representing highway MPG and the x-axis representing the number of cylinders. Add a trend line to the scatter plot to assess the significance of the relationship and analyze its slope. Calculate the correlation coefficient to determine the strength and direction of the association between the number of cylinders and the highway MPG. Coming to the Excel sheet. Here we can see the engine cylinder and the highway MPG are here. To know the relationship between, I have used the scatter plot with a trend line. Here you can see in the y-axis we have highway MPG. In the x-axis we have a number of engine cylinders. As the number of engine cylinders increases, the highway MPG decreases. Here you can see, as the car having a number of engine of 14, sorry, the car engine having 14 cylinders has the 16 cylinders has the highway MPG of 14. So it is a negative correlation. To find the correlation, I have used this above formula, correl. So coming to the report, the investigation reveals a negative association between highway MPG and the number of engine cylinders, indicating that as the cylinder count increases, the highway MPG tends to decreases. For example, car with 16 cylinder exhibit the lowest highway MPG of 14, illustrating the impact of engine capacity on fuel economy. Furthermore, a correlation coefficient of minus 0.61 highlights a relatively significant negative relationship between the number of cylinders and highway MPG. This statistical measure quantifies the strength and direction of the relationship, indicating that as the number of cylinders increases, highway MPG typically decreases. This is the graph. So next, coming to the building dashboard, the first task is to illustrate the differences in automobile pricing distribution across brands and body style. Creating a stacked column chart showing the distribution of automobile cost by brand and body type. Use slicers and filters to add interactivity to the chart. Determine the total MSRP for each brand and body type using SUMIF or pivot tables. This will provide comprehensive insights into how pricing varies across different brands and body style. So coming to the Excel, here for dashboard task 1, here you can see the pivot table I have created for brand, that is make, vehicle style and MSRP. So here you can see the make I have inserted it for rows. In columns I have inserted the vehicle style, and in values I have inserted the MSRP. So this is how the pivot table created. Here I have created a bar column clustered column chart, stacked column chart for this data. I have used the slicers. In order to insert the slicers, go to the insert, and here you can see the slicer. Click on the slicer and which one you want, which column you make and vehicle style I will select and click on OK. Here you can see the slicers are created. By selecting this, you can see, for example, for the brand Aston Martin, for the vehicle style scope, we have the average MSRP of that is 90 lakh. So in order to clear the filter, click on this. Yeah, coming to the report. After conducting this study, we have discovered that Chevrolet leads in total prices with 31 lakh, that is 3 crore 14 lakh 87,928, followed by the Mercedes-Benz with 2 crore 45 lakh 75,709, making it the second highest. In terms of car types, sedans have the highest total cost of 11 crore 50 lakh 33,523, followed by 4-door SUVs at 9 crore 91 lakh 37,486. These findings offer valuable insight for the car industry's marketing strategy, product development initiatives, and pricing distributions. This is the column and chart that have been created in the Excel. Moving on to the task 2 is to compare the typical MSRPs of the most and least expensive car manufacturers as well as their variations across different body types. Create a column chart with clusters to visualize the average MSRPs of various car manufacturers and their body types. Determine the average MSRP for each brand and body type using pivot tables or the average if function. This will allow for the comprehensive comparison of pricing across different manufacturers and body style. Coming to the Excel. So dashboard task 2. Yeah, you can see the same pivot table we have copied from the task 1, and we have just changed the sum of MSRP. Here you can see the sum of MSRP in the column in the task 1 to the average of MSRP. Here this is done by selecting the value field settings here. So this is the chart, column chart, clustered column chart I have created. Here you can see the Bugatti has the highest MSRP here, followed by the Maybach. Here you can see convertible point Maybach. Coming to the report. In brand analysis, Bugatti stands out with the highest average price, followed by the Maybach. As for body styles, convertible has the highest average price, closely followed by the Coupes. Conversely, Plymouth has the lowest average price brand, with Oldsmobile coming in second. Among body styles, two-door SUVs are the most affordable, followed by the two-door hatchbacks. This research provides valuable insights into price patterns across various car markets. So, moving on to the task 3, to analyze the effects of features like gearbox type on the MSRP and how this varies depending on the body type. Create a scatter plot chart where the x-axis represents the MSRP and the y-axis represents the engine type, and each body type is represented by distinct symbols. Determine the average MSRP for each combination of the body part and engine HP using average ifs or pivot tables. This will allow for a comprehensive understanding of how engine type influences the MSRP across different body types. So moving on to the Excel. Here we can see we have the columns transmission type, MSRP, vehicle style. I have created this pivot table. Here you can see the pivot table I have created this according to the vehicle style and the transmission type. So this is the scatter plot I have used. Here you can see the coupe, the vehicle type coupe automated manual has the highest MSRP, followed by the automated manual transmission type convertible vehicle style has the second highest MSRP. So coming to the report. When considering transmission types, automated manual transmission has the highest average price, closely followed by the direct drive transmission. In terms of body shape, convertible has the highest average price, with Coupes following closely at $77,000. Conversely, manual transmission ranked second, while unknown transmission have lowest average price. Among body shapes, two-door SUVs are the least expensive and followed by the two-door hatchbacks. These insights provide valuable information for understanding price trends in the car industry across various body shapes and gearbox types. So this is the chart that I have been used in the Excel. Moving on to the task 4, to examine differences in automobile fuel economy across different model years and body style. To create a line graph displaying the fuel economy trend, that is MPG, over time for each body type. Determine the average MPG for each combination of body type and model year using average ifs or pivot tables. This will provide insights into how fuel efficiency varies across different body styles and model years. Coming to the Excel, task 4. Here you can see we have the data here: vehicle style, highway MPG and city MPG. Here you can see I have only the year and the average highway MPG. By clicking on this, you can see the vehicle body type. What I have done is I have made year and vehicle style both in the rows column, whereas highway MPG in the values column, so that my graph does not look clumsy. So here you can see by the year 2016 has the 2016 model has the highest highway MPG, that is 29.5. As the year as the model year of the model increases, the highway MPG also increases. Coming to the report, the data suggests as a trend towards increased fuel efficiency as car model years progresses. This could be attributed to advancements in automotive technology and regulations aimed at reducing emissions and enhancing fuel economy. The most recent model year in our dataset is 2017. The highest average highway MPG is 40.3, achieved by 4-door hatchbacks in the year, reflects ongoing efforts to improve fuel efficiency. Conversely, cargo vans has the lowest average MPG at 16, underscoring the variations in fuel efficiency across different vehicle categories. Moving on to the task 5. What differences exist across brands in terms of car price, horsepower and MPG? Use a bubble chart to see how price, MPG and horsepower related to one another for various auto brands. Give each brand a distinct color, then write the name of the automobile model on the bubbles. Using average ifs or pivot table, get the average power, horsepower, MPG and MSRP for each automobile. Let us go to the Excel sheet. Here you can see the task 5. We have the data: make, engine HP, highway MPG, MSRP. Here you can see I have took the average of engine HP, highway MPG and MSRP. So this is what they have asked in the question. Let me show you how to create the bubble chart. By using pivot table you can't create the bubble chart. See, I will show you. Here it shows you can't create using the pivot table. So I have copied this entire pivot table as a separate table. So here I will show you. Go to insert and here under charts go to bubble chart. Here initially it shows like this. You can't determine how the data is. So in order to make this, so click on here, go to select data. Here you need to select only the data. So I will select. Then click on switch row or column. So after that click OK. Now you can see our data has been created. Now you need to add this data labels, that is which one has the bigger circle and all. So click on this chart, go to this plus symbol and here you can see the data labels and arrow will pop out. Here click on more options. Here go to the chart properties. In here label options. Here in order to display the values you need to select values from tables. So I need to select the range, that is the brand. So click OK. Then here you can see the bigger circle is having Bugatti. So I don't want this Y value. So click on this value. Yeah. Now you can see. Then you want this in the center. So data level click on center. So again we don't want this x value also, just need the value, that's it. So you need to deselect this x and y value. In the same way I have used the different color. See, for a different type of, see, you can see by seeing this, Bugatti has the highest average of MSRP, followed by the Maybach. Coming to the report, indeed Bugatti leads with the highest average engine horsepower of 1001, with the highest average highway mileage of 14 and the highest average cost. Conversely, Tesla boasts the highest average highway MPG of 99, with the highest average engine power of 538, with the highest average price of 85,000. In conclusion, Bugatti's high-performance cars appeal to those seeking unmatched performance, offering top-tier engine power and pricing. On the other hand, Tesla's focus on electric vehicles highlight their impressive price and fuel, catering to environmentally conscious customers. This comparison underscores the diverse goals and preferences within the automobile industry, serving a wide range of customers with different needs and interests. So this is the pivot chart I have created in the Excel sheet, and this is the scatter plot to know the relationship between the horsepower, MPG, price across different car brands. Let us move to the Excel sheet. So coming to the next one, by creating the dashboard, by doing this all task 1, task 2 till task 5, we have combined all these graphs together in a single dashboard. Here you can see this is the dashboard of our task. So we have sliders. All sliders are attached to the all these sliders are attached to all this data except these two, because these two cannot be created using the pivot table. So I have created the separate. So for example, for BMW, see, the data for the BMW will be displaying here. In the BMW 4-door SUV, so you can see when it comes to this one, for year 2011, what will be the efficiency of fuel, like that. In order to connect all this data together, just right click on this slicer and you can see report connection. So this make, that is brand name, is connected with the pivot table 1 and 2. You can deselect so that it will not link each other. So we want all these to be included to the single slider. So I have selected both the pivot 1 and pivot 2 table. So this is the dashboard. You can see the first one is distribution of car prices by brand and body style. The second one is average prices across different car brands and body styles. Third one is the trend of fuel efficiency over time. Fourth one is the relationship between the transmission type and the average prices. Fifth one is the relationship between horsepower, MPG and the price across different car brands. So this is the dashboard I have shown there. Yeah. Now moving to the last and final part of our presentation, that is result. Through these studies, I have gained a valuable insight into the automobile industry, including shifts in vehicle features, pricing dynamics, and fuel economy. I have observed correlations between engine power and price, and the influence of market segments on car popularity, and the impact of transmission type on pricing. Looking ahead, future research could explore how emerging technologies such as electric and driverless cars are booming in the industry. Additionally, investigating Demographic changes and consumer preferences may provide further insights into customer behavior. Understanding industry trends could also evolve, examining the effects of sustainability initiatives and environmental regulations on automobile design and production. Overall, there are numerous avenues for future studies and analysis to continue exploring and understanding the ever evolving landscape of the automobile industry. Thank you for this great opportunity to present this project.